Enterprise AI starts with trustworthy data. In this section, we'll connect Azure ingestion, storage, search, and analytics services into a platform that can handle streaming, structured, and unstructured data, and prepare it for AI and GenAI workloads. So far, we've built the architecture foundation: TOGAF thinking, ADM execution, Azure landing zones, and identity controls. Now we move into the data platform layer, where ingestion, storage, analytics, and search decisions prepare the ground for AI, GenAI, and integration architecture. Enterprise AI doesn't fail only because of weak algorithms. It often fails because the data is fragmented, untrusted, or uncontrolled. The architecture underneath determines whether models can retrieve the right context, meet compliance requirements, and scale from pilot experiments to production value. Azure Storage acts as the durable landing zone for AI data. Blob storage works well for object-like data: PDFs, images, logs, exports, model files, and raw documents used in retrieval workflows. When that data needs analytic scale organization, Azure Data Lake Storage Gen 2 adds a hierarchical namespace, so teams can manage folders, partitions, permissions, and pipelines more naturally. This choice is not just about where files live. It also affects performance tiering, redundancy, private network access, encryption, and governance controls that determine how safely and efficiently AI systems can use the data. An enterprise data lake should be a controlled maturity pipeline, not a dumping ground. Data enters in raw or bronze form, preserving source fidelity for audit and reprocessing. It then moves into cleansed silver, where quality, standardization, and access controls improve. Curated gold datasets are shaped for trusted business use. Finally, AI-ready assets add the structures models need, such as embeddings, metadata, lineage, and domain context. Organizing by domain, sensitivity, source, and retention keeps growth manageable and supports TOGAF governance, while separating ingestion from consumption helps prevent accidental sprawl. Storage governance makes data useful without letting it become expensive, exposed, or non-compliant. Lifecycle policies automate movement between hot, cool, cold, and archive tiers, so retention and cost follow actual usage. Encryption protects data at rest by default, and key ownership becomes a design decision. Microsoft managed keys for simplicity, or customer managed keys for tighter control. Access should be layered, not dependent on one setting. Combine Entra ID, RBAC, ACLs, managed identities, private endpoints, and network rules. Then tie every choice back to classification, regulation, ownership, and architecture standards. Ingestion pattern selection comes down to freshness and pipeline guarantees. Batch works well when data can arrive on a schedule, such as nightly exports, historical archives, or document collections. Streaming is for continuous signals, telemetry, user behavior, IoT readings, and operational monitoring, where seconds matter. Event-driven ingestion sits between them. Processing starts when something happens, like a file landing or a message being published. The right design balances latency, volume, reliability, ordering, replay, and the needs of downstream consumers. Azure Data Factory is the control plane for batch data work. Instead of hand-coding every movement, you define pipelines that trigger on a schedule or event, connect to sources across on-premises systems, SaaS, databases, storage, and analytics, then copy, transform, validate, and land the data. The important part is orchestration. Dependencies, parameters, retries, logging, and alerts make the flow repeatable and supportable. For AI systems, these pipelines often refresh curated datasets, ingest documents, prepare search indexes, and notify teams or services when each batch is complete or needs attention. Event Hubs is the front door for fast-moving data: app events, device telemetry, logs, and system messages. It accepts the stream at scale, then partitions it so many consumers can read in parallel. Stream Analytics turns that raw flow into decisions by applying time windows, filtering noise, joining streams, and calculating aggregates as events arrive. The outputs can drive dashboards, alerts, functions, storage, or machine learning actions. Design details matter here. Throughput units, consumer groups, checkpointing, and durable downstream targets determine whether the pipeline stays reliable under real-time load. Azure functions are useful when an AI pipeline needs a small action to happen automatically. A new blob arrives, a queue message appears, an event stream updates, or a timer fires, and the function runs just enough code to respond. That code might extract metadata, validate a file type, normalize a document, call an enrichment API, or trigger indexing. Because functions can use managed identities, they can reach storage, key vault, search, and AI services without embedded secrets. Keep them focused and short-lived. For complex branching or long-running workflows, use durable functions or data factory. Processing pattern choice starts with the business question, not the technology. If value comes from complete, trusted history, use batch, scheduled pipelines, heavy transformation, and curated datasets. If value depends on what is happening right now, use streaming, telemetry, monitoring, fraud signals, or AI decisions that must react immediately. If the need is lightweight coordination, use event processing to enrich a message, trigger a workflow, or connect systems. Most enterprise architectures combine all three. Batch creates the authoritative record. Streaming adds operational awareness. Events provide automation between services. The right answer balances latency, complexity, governance, cost, and downstream analytics needs. Azure AI Search is the retrieval layer that turns enterprise content into something applications can actually use. Documents, databases, and files are ingested, then enriched with AI to extract text, entities, language, and key phrases. That enriched content is organized into search indexes where metadata and structure make retrieval fast and precise. Queries can use classic keywords, semantic ranking, vectors, or hybrid search, depending on the experience you need. In production, the critical decisions are governance decisions: schema design, refresh cadence, access control, content quality, and lifecycle management. Retrieval quality depends heavily on how content is prepared before it reaches the model. Chunking turns long documents into passages small enough to embed and retrieve, but still meaningful enough to preserve context. If chunks are too large, retrieval gets noisy. If they are too small, answers lose meaning. Metadata adds the control layer: source, date, department, document type, classification, and access group. These tags help the system filter for relevance and enforce permissions. Done well, retrieval produces grounded answers with citations. Done poorly, it can return irrelevant results or expose information. Modern AI retrieval works best when relevance and security are designed together. Semantic search interprets meaning, so a user can ask in natural language and reach the right content. Vector search compares embeddings, helping find conceptually similar passages even when the wording is different. In enterprise systems, hybrid search combines keywords, semantic ranking, and vectors, then applies metadata filters. Before results reach an AI app, identity controls enforce permissions through Entra ID, RBAC, document-level access, private endpoints, encryption, and audit logs. The goal is better answers, drawn only from data the user is allowed to see. The key message is simple. Strong AI architecture starts with strong data architecture. Azure Storage and Data Lake create the secure foundation. Ingestion and processing turn raw data into reliable, timely signals. Azure AI Search makes enterprise knowledge retrievable for grounded GenAI. Next, we'll build on this foundation with Azure AI services, then connect them into complete application architectures.